Section 10.4 is about hyperbolas. What are hyperbolas? Well, I like to start with the definition. What is a hyperbola? Hyperbolas are defined as a set of points. The difference of whose distances from two fixed points is a constant. These two fixed points, we call them foci, as we did in ellipses. So what does it say here? So let's look at the hyperbolas like this for now. So these, if you pick any point on the hyperbola, call this f1, f2 as foci. The difference between this distance and this distance, let's say, so I f2 minus I f1, and you usually put an absolute value, it's constant. That's the definition of hyperbola. So if you pick any point anywhere and find the difference of these two distances, it's gonna always give you a difference. And why does that help us? Because from this definition, we can find the equation of the hyperbola, which I'm gonna list down later on. For the meantime, I'm gonna analyze a hyperbola graph. So if we have a hyperbola like this with two branches, so the hyperbola, there are two options, either opens right, left, or up and down. So let's look at the right, left. Inside these, those are the foci, f1, f2, the foci. In the middle, that's the center. That's I, the center. This distance is always AA. These are vertices, V1 and V2. Okay, so we have f1, f2, foci. V1, V2, vertices. If we go B distance up, B distance down, B distance up, B distance down, like that, and connect them this way, these lines are called asymptotes. So we have two lines, call them line 1 and line 2. L1 and L2 are called asymptotes. So we have foci, vertices, center. I is the center. Always gonna have coordinates h, k. We have vertices. We have asymptotes. And the foci. So the distance, as I said, this is B, this is A, the horizontal distance A. So the equation of the asymptotes is y minus k from the center equals plus or minus, there's x minus h. So the slope here for the line is the rise over run. So it's B over A. So plus or minus B over A. These are the asymptotes. The equation of the hyperbola is x minus h squared over a squared minus y minus k squared over b squared equals 1. Is almost the same as the ellipse, except the middle sign is minus instead of plus. Now here a does not have to be bigger than b. A does not have to be. So always a is located here, always in the first one. If the hyperbola starts with x, like the starting here, x not y, then it opens to the right and left. If it starts with y, y minus k squared over a squared, notice how a stays as is, and x minus h, always h attached to x, k to y, then this opens up and down, up and down. This opens up and down. So right, left, up and down. The other information we need to know from the graph, you can see it as well. This distance from the center to the focus, that's a C distance. The same thing on this side, that's a C distance. So the relation between A, B, and C is C squared equals A squared plus B squared. In ellipses, it's a square minus b square. So that's pretty much everything you need to know for this lesson or this section. All we try to find now is to work out how to work out problems. Okay, how we work out some questions. So let's start with kind of like analyze the equation or the hyperbola. Let's say x minus 1 square over 9 and put 16 here, y square equals 1. So we're going to analyze this, find everything about it. First thing I always find is the center. Center has coordinates 1, 0. That's the center. We have always the first number is a square. From here we can find a. The next number is always b square. From here we can find b. From these two I'm going to find c. C square is a square plus b square. A square is 9, b square is 16, that's 25. So from here c is 5. Notice the hyperbola starts with x, so it's going to open to the right and to the left. So start with the center, 1, 0. Plot the given is the key to solve a lot of questions. 1, 0, that's where the center is. And a is 3, so from this one you go 1, 2, and 3. That's the first vertex, so it's going to go this way. 1, 2, and 3 this way. So that's -1, -2. This is V1 and V2. These are the vertices. Okay. And then the other thing is the asymptotes will look like this, graphing wise. I'm just graphing it. With plotting the graph, it was easy for me now to find the vertices. Coordinates V1 4, 0 and V2 is -2, 0. Those are the vertices. We have the center. Foci, remember C is 5. So from here you're going to go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So the foci, F1 at 6, 0, F2 at -4, 0. What else we need to find here? So we found the vertices, foci, center, asymptotes, right? It's y minus k is plus or minus rise over run, b over a, x minus h. So the b here, we found the b was 4 and a 3. 4 over 3. The center was 1, 0. So then the equation becomes plus or minus 4 over 3 times x minus 1. Those are the asymptotes. Now note, in case the hyperbola starts with y minus k square over a square, x minus h square over b square equals 1, then the asymptotes will have the equation y minus k plus or minus, instead of b over a becomes a over b. X minus h stays the same. So I'm going to analyze another one. Analyze y plus 2 square over 16 minus x minus 2 square over 4. Now what's the center? It's 2, -2. 2, -2. That's the center. A squared always the first number, so a is 4. B squared is the next number, so b is 2. From these two we can get c squared. A squared plus b squared. 16 plus 2, 20. So c is the square root of 20. Can be simplified as 2 square root of 5. That's c. We got h comma k. We got a, b, and c. Now we can plot the given. Give yourself enough space. A is 2, negative 2, and the center. It starts with Y. Do you see? It starts with Y, so it's gonna open up and down. Up and down. A is 4, so you're gonna go from here 4 units up. 1, 2, 3, 4. That's the first vertex. So the parabola is gonna go like this. Next one, negative 3, negative 4, negative 5, negative 6. It's gonna be here. So these are the vertices, V2. So I can list down the vertices, V1, 2, 2, and V2, 2, negative 6. Oops. Foci, we need to go from the center 2 root 5 distance up and down. So it's 1, 2, somewhere here. Because if you try to put 2 square root of 5 on the calculator, it will give us 4.47. So that's where F1 is located. And then if you go down somewhere here, 2 root 2 down. So what happened? You have from here to here, it was a negative 2. And then from here to here, negative 2 root 5. So F2, both of them, they have x equals 2. But F2 went down negative 2 minus 2 square root of 5. For the next one, we need to go, we went from here 1, 2, 3, 4, and something. So this distance, we need to figure out how far is this above the x-axis. So let me use a different color. From here to here is 2 square root of 5. But to find out the coordinates, the y coordinate of this, we need to find this distance, which is 2 square root of 5 minus 2. Okay, so graphically, that's how we found it. Graphically, I got the vertices, the foci, the center, and we need the asymptotes. Again, the equation is y minus k plus or minus, let me see, a over b, not b over a over b, x minus h. Let's check that out. This was 2, negative 2, so negative 2, and there's a 2 here, plus or minus, a was 4 and b2, 4 over 2. So that gives us y plus 2, plus or minus 2 here, x minus 2. And you can leave it like this, it's fine. So that's how we analyze the equations. They give you the equation, and then you are required to get everything required from us. What about another one, but in a different way? Let's say y squared minus x squared minus 4y plus 4x minus 1 equals to 0. How do you do this? Here we need to complete the square. We combine or group the y's, minus x squared plus 4x together, minus 1 equals 0. For this one, we divide the coefficient of x by 2, that gives us 2. And squared, you get 4. So add 4 here and 4 there. So far. So this whole thing becomes y minus 2 squared. Take out a negative sign here. That'll leave x squared minus 4x minus 1 equals 4. Then divide this by 2, you get 2. Squared, you get 4. Add 4 and subtract 4. So this can be written as a complete the square. X minus 2 squared minus 4 minus 1 equals 4. So then y minus 2 squared minus x minus 2 squared plus 4 minus 1 equals to 4. These cancel out if you subtract it. So you get y minus 2 squared minus x minus 1 squared. Add 1 to both sides. So notice a and b here are both, or a squared and b squared, both of them are 1s, which is okay. This has a specific name actually in mathematics called equilateral hyperbola. But you don't need to know this, equilateral hyperbola. So the center here, it's 1 comma 2, that's I. A squared, as I said, is 1, b squared is 1. So from here a is 1, b is 1. So we can get c squared is a squared plus b squared. So c squared is 1 plus 1, 2. So c is the square root of 2, distance-wise. So I'm going to plot the given. 1, 2 is the center. That's the center. It starts with y. So it's going to either open up or down. Let's see. So we have to go up a distance. That's the vertex. Down 1. So 0, 1. So we got v1 and v2. v1 has coordinates 1 comma 3. v2 has 1, 1. C, you have to go up root 2. So from here to here, let's say f1 is here. This is root 2, square root of 2. And down square root of 2. This is f2. So to find f1 has 1 comma something. 1 comma something. So 1 comma 2 plus square root of 2. Next one. 2 minus square root of 2. 2 minus square root of 2. And that last thing is the asymptote. Y minus h, k equals plus or minus a over b, x minus h. H was 1 and 2. So y minus 2. This was 1, 1. And h again is 1. So that gives us y minus 2 is plus or minus 1, x minus 1. You can leave it like this or add 2, but that's more than enough. Other kind of examples, good to ask, is how to find the equation of each hyperbola. So each equation with the given information. So let's say they give us number 1 or part 1. Let's say the center at 0, 0, focus 0, 5, vertex at 0, 3. Just to start with this. Easy stuff. Always plot the given. That's the key to solve a lot of problems in conics. 0, 0 is the center. 0, 3 is the vertex. 0, 5 is the focus. So what do I need to really solve or find the equation? I need to write down the formula first to see what is missing. So a squared minus y minus k squared over b squared. So for the meantime, I started with x minus, but then I need to change it if I'm supposed to. Well, let's see. The vertex is over there and the focus must be inside it, must be inside the hyperbola. So it must go this way. So this means it must start with y. So y minus k and x minus h. X minus h. So h and k 0, 0. Those are hk. I need a and b. A is the distance from here to here. A is 3. From the focus, this is the c distance, which is 5. From these two, I'm going to find b. So c squared equals a squared plus b squared. 25 equals 9 plus b squared. 16 is b squared. So I found b squared. So now we substitute. Y minus 0 squared over a is 3. X minus 0 squared. B squared is 16 equals 1. So that gives us y squared over 9 minus x squared over 16 equals 1. part 2. Let's say they give us vertices negative 6, 0, or no, negative 4, 0, 4, 0, asymptote with the equation y equals 2x. Let's see what we can do. So vertices 4, 0, negative 4, 0. So this means the hyperbola is going to go this way. So the center is 0, 0. I got the center. From here to here, that's A. A is 4. So I have A. What is B? We need to find B. Well, I use the vertices. I haven't used the fact that the asymptote is given. Remember the equation, the asymptote is K, y minus K. And since it opens to right and left, it's plus or minus B over A, x minus H. It's given to us as y equals 2x, like that. So it's like minus 0, minus 0. So b over a, or plus or minus b over a, is 2. But we found a is 4, so substitute that in. Cross multiply, plus or minus b is 8. If you square both sides, because I need ab squared at the end, it's 64. So the equation becomes, it starts with x because it opens to the right and to the left. X minus h squared over a squared minus y minus k squared over b squared equals 1. So we get x minus 0 squared, y minus 0 squared. B, I found it 64, and a was 4, so that's 16. So the final answer is x squared over 16 minus y squared over 64 equals 1. So always you need HK, A, and B, then you're done. Exactly the same way as we did with the ellipses. We have to find just HK, means the coordinates of the center are required. A and B. Keep in mind two important things. That in here C squared is A squared plus B squared. And also in any conic you work with, you plot the given. When you plot the given, you can find everything you need. You can see everything, and make sure graphically where is A located, where is B located on the graph, where is C located on the graph, the vertices, the foci, the center, the asymptotes. If you know these things, how they're located on the graph, as the same way as when I started the lesson, this becomes very easy for you.